Day 4, Streaming, Latency, and Token Budgeting. Today we're stepping into the world of speed, how fast your AI responds, how natural it feels, how much it costs. The model thinks silently in its head, finishes the whole answer, and then sends it to you all at once. With streaming, the model sends tiny pieces of the answer the moment each piece is ready, just like watching someone's typing bubbles appear before they finish the message. Streaming transforms the model from a robot into something that feels alive. Real example. Koala Dental Voice Agent. A patient asks, "Do you take emergencies?" Without streaming, the AI waits, finally responds after 1.2 seconds. It feels slow and stiff. With streaming, the voice begins almost instantly. Yes, we do accept emergency patients. Natural, conversational, human. This is why all real voice agents must use streaming, and the exam knows this. Part 2, Invoke Model versus Invoke Model with Response Stream. AWS gives you 2 ways to talk to models. The one, Invoke Model. This is the classic way. You send a request, the model works silently, and you get one full answer. Use this for batch scripts, offline reports, large RAG responses, long summaries. It's predictable but slow to the user. 2, Invoke Model with Response Stream. This is streaming mode. You get text token by token, like you can see the code in our conversation history. You see the answer forming instantly. Use this for voice agents, live chat, web apps needing instant response, low latency or user-facing workloads. And the exam is very clear. When they mention real-time, voice, latency, or fast, streaming is always the correct choice. Part 3, what is latency? Latency is simply how long until the first token appears, not the whole answer, just the moment the model starts talking. Latency is the difference between a bot that feels responsive and one that makes users think the line dropped. Real latency. Claude models compared. Claude Haiku, lightning fast. First token in around 0.2 seconds. Claude Sonnet, balanced. First token around 0.7 seconds. A genius, but slow. First token often over 1.2 seconds. So if the exam says, a phone system needs a response in under 300 milliseconds, the correct answer is Claude Haiku plus streaming. How to measure latency. Whether you use the CLI or code, the idea is the same. 1, record the time you send the request. 2, record the moment the first token arrives. 3, subtract. That number is the latency. That's it. Part 4, token budgeting. Now we shift from speed to cost and efficiency. Tokens are the little pieces of text that the model reads and writes. And yes, both directions cost money. 3 token types. 1, input tokens, your prompt, RAG context, instructions. 2, output tokens, what the model generates. 3, context window tokens, the maximum allowed. Why token budgeting matters. Lower cost, lower latency, higher accuracy, fewer hallucinations. Token control is production engineering. How to reduce token usage and what the exam expects. 1, shorter prompts. Long poetic system messages waste money. Bad, you are a lovely assistant that will carefully think through every detail. Good, you are Koala Dental's receptionist. Be concise and factual. Fewer tokens, cheaper, faster. 2, limit output size set. You can see the code in our conversation history. Instead of letting the model ramble, this alone can cut costs by 70 to 90%. Try 3, use RAG. RAG reduces how much the model must think because you give it the right information. Less reasoning, fewer output tokens, fewer hallucinations. 4, avoid unnecessary few-shot examples. Examples are powerful but expensive. Use them only when needed. Pick the right model. Choosing Opus for a simple greeting is like using a Ferrari to deliver Uber Eats. Haiku, fast and cheap. Sonnet, balanced and accurate. Opus for deep reasoning only. The exam loves punishing bad model choices. Real cost comparison. Task, write a dental greeting. Opus, expensive, unnecessary, slow. Haiku, fast, cheap, and perfectly good. In production, this difference becomes thousands of dollars per month. Part 5, full real-world architecture example. Your dental chatbot must respond in under 1 second, stay accurate, avoid hallucinations, stay affordable. A strong design is model Claude Sonnet, retrieval, Titan embeddings v2, streaming optional for chat, required for voice. Token limits, max tokens 80, prompt, short, structured, no guessing. This is the blueprint AWS wants you to think in. Part 6, memory tricks so you can't forget. Streaming, send the answer while typing. Latency, time until first token. Token budgeting, pay per word and per context. Model choices. Haiku equals fast, sonnet equals accurate, opus equals smart but slow. These few lines will save you from the trickiest exam questions. Final cheat sheet. Streaming, use invoke model with response stream for voice agents, chat, low latency systems. Latency testing, measure time to first token. Haiku, sonnet, Mistral, opus. Token budgeting, reduce prompt length, limit max tokens, use RAG, choose smaller models when possible. Master these, and the Day 4 topics become easy points on the AWS exam and real-world superpowers for building fast natural AI agents like Koala.